myself Mr. Gautam Kumar, Assistant Professor MMCT BM, IIM Deemed to be University Malana. My subject is System Analysis and Design, subject code BCA 204. Today we are going to discuss about the data dictionary and decision tree, which are the commonly used tools for the structure analysis. And in previous lecture we have discussed about the DFD also. So, in today's lecture we will discuss about the introduction of data dictionary, advantages of data dictionary, elements of data dictionary and decision tree. In our data flow diagram, that is the DFD, we give name to the data flows, process and data stores. Although the names are descriptive of the data, they do not give details. So, following the DFD, we have to build some structured parallels to keep details of the content of the data flows, processes and data stores. A data dictionary is a structured repository of data elements in the system. It stores the descriptions of all DFD data elements, that is details of data flows. Data stored in the data stores and the processes. There are some advantages of using data dictionary and these are as follow. The documentation, it will a documentation and that is valuable for the reference in any organization. The data dictionary can be used as a reference document. It improves analysis user communication by establishing consistent definition of various elements, terms and procedures. It control information maintained for each data element in cross reference in a data dictionary, and it is important step in building a database. Most database management system have a data dictionary as a standard feature, and it is important step in building database. So, that is the reference table which you can see on the screen. Like we have serial number 1, 2, 3, 4, we have the data name like ISBN, title, sub and a name, and the description of these data names is ISBN is the ISBN number of the book, title is the title of that book, sub is for the subject's book and a name is used for here. The description of a name is data name, a name is used for the author name, and we have the further information about the ISBN that is used for as a data element in the database. We can use here the 10 numbers or 10 characters are sufficient to store a ISBN number, same as we have 60 characters for storing a title, and for subject we have the 80 characters, and for the author name we have the 15 characters. So, it is giving an overview which data element we are going to use and how many characters we can use to store the data or information in that particular data name or data element, and description will give you the information about that which type of data it is going to hold and which type of data we are going to store in particular data name or data element. So, on the screen you can see the sample project data element form, in which we have some columns like we have a project name, the project name will be there, the date on which we are assessing we are doing the assessment. We have some columns like project element, seed data, element descriptions. Here we the analyst will provide the description of the data element abbreviation which we are using, element picture if it has some pictorial presentation we will provide it here, element location where the element is stored in the system, an element source from where we are getting that data element. So, all the details will be there in a sample project data element form, and this is the form that has the rigorous definitions of all the DFD elements and the data structures. So, all the DFD element name will be there, their abbreviation will be there, their pictures, as we have discussed in previous lecture. DFD have some notations or pictorial notation to represent element of DFD. All things will be there for a reference purpose. There are some items that we have to define while we are creating a data dictionary. The data dictionary is a repository for storing the data for a system. So, there are three type of items in data dictionary which we have to define while creating a data dictionary for a system during the structure analysis. The first one is the data element. It is the smallest unit of data that provides for no further decomposition. So, data which we are going to store and that cannot be further decomposed in any other sub items, that is the data element in our system. For example, date consists of day, months and year. They hang together for all practical purpose. So, if we are talking about the date, so there is a format, the date should have the day, month and year, and without or decomposing it in the day, month and year, it is no more date. If we are only using month and year, that is not a complete date. If we are using day and month, that is not a complete date. So, the date cannot be decomposed further. That is the example for data element. Like second element which we have to define in data dictionary is data structure, a group of data elements handled as a unit. So, in data structure we have a group of data elements, we have a bunch of data elements that is handled together, and it is a data structure. For example, I am here taking an example of the book detail. Book detail is a data structure and it consists of the data elements like author name, who is the author of that book, the title of the book, ISBN number, that is International Standard Book Number, for it is a unique number for that book, publisher's name, who is the publisher of that book. So, they are several data elements like author name, title, ISBN number and publisher name, and that are handled together, that are in a group, that is a data structure, and we can say that that is a book detail. And data flows and data storage, that is the third element that we have to define during creating a data dictionary for a system. Data flows are data structure in motion. Some data is flowing from source to destination in system, whereas the data stores are the data structure at the rest. So, data flows is the data structure which is in motion, which is being used from destination to source, which is traveling in the system, and data storage are the, or data store is a data structure which are in rest, which are stored somewhere and they are not moving or flowing in the system. A data store is a location where data structures are temporarily located. On the screen we have the logically data description hierarchy, how the data is having the description in the data dictionary. First of all, we have the data element and it is the smallest unit of the data that cannot be further decomposed, and after that we have the data structure. Here we have the data structure and that is the group of data elements. We have several data elements in a bunch as we have discussed in previous slide, like book details having the title, author name, ISBN number and publisher details as the bunch of data elements, which is the data structure book details. And the data structure or group of data structure, the group of data structure can be a data flow and a data store. If data that structure is in a flow or in a motion, at that time that group of that data structure will be referred as a data flow, or if it is in rest, the group of the data structures in system are rest, that is the data store. You can easily understand the hierarchy of data element, data structure, data flow and data store in a data dictionary during the structural analysis. How we can describe the data elements? The descriptions of a data element should include the name, a description and alias. So, while we are describing a data element, we focus on the name of that data element, what alias we can use and what is the description of that data element. For example, here we are taking an example of the author name, and that author name can be further divided in first name, middle name and last name, and that is the description having the first name, middle name and last name and the alias. Like here we are taking an example of Dr. R. Nageshwar Rao. So, the doctor is the salutation. If we are talking about the Nageshwar Rao, so there are two things. The first name is Nageshwar, middle is there is no middle name, we can leave it blank, and last name is Rao, and we can use the alias like NR, Nageshwar Rao. So, during describing a data element, we can provide description, name of that element and the alias we can use to refer that data element during the system implementation or system functioning. The description should be a summary of the data element. We may also want to include whether or not the data element have. So, we have to keep some point in our mind during describing the data element, like first of all we have to include a different name. For example, a purchase order may exist as a POR.order, purchase ORD, P.O. We want to record all these in the data dictionary and include them under the purchase order definition and separately with entries of their own. So, they are the different names used for a single data element, like purchase order can be POR.order, purchase ORD and PO. So, we have to provide a summary of description under the definition of the purchase order. Uses categories, characteristics such as the range of value or the frequency of use or both. A value is a code that represents a meaning. We have two type of data elements, value within range. For example, payroll between 1000 and 10,000 is equal to continuous values. We have a second type of value, that is specific value, like departments in a firm coded 100, that is for the accounting department, 110 for the human resource and 111 is for the operations. So, on the basis of uses, we have two type of data elements, the continuous value that can be used for the, for example, payroll. The pay of different employee can vary from a minimum to the maximum pay value, and a specific value, as we are taking here an example of a firm, we are having some codes for the department, like 100 for the accounting, 110 for the human resources, 111 for the operations. control information such as source, date of origin, users or access authorization. For example, looking for the properties of Word document. If we have a document created with the MS Word, so that is the control information. If we are looking for the date of origin, when we have created that document, who created that document, who is the author, and access authorization. So, these are related to the control information for a data element. And the physical location in terms of record of file or database, where that database or that file is located physically. For example, where storage is done in C drive, D drive, or it is a stored in a CD that can be accessed by a CD-ROM. So, these are several points which we have to in our mind while describing the data element. Now, how we can create or how we can describe the data structure during the creation of the data dictionary. Data structures are the group of data elements, bunch of data elements together, and we describe any data structure by specifying the name of each data structure and the elements it represent. Some elements are mandatory, whereas others are optional. As earlier when we are discussing about the data structure, we took an example of the book detail, where we have some data elements related to the author name, publisher, ISBN number and title. So, during the data structure, while we are describing the data structure, we have to keep in our mind which element are mandatory and which are not mandatory. Like we are here an example of again about the book detail. So, data structure name is the book detail, and that data structure having the data elements like author name, title of book, edition, ISBN number, publisher's name and quantity order. So, there are two columns which having the information about which data element is mandatory and which is optional. Like author name is mandatory, so it has the yes, author name is mandatory for any data structure named as book detail. Title of book, it is also mandatory. Edition, it is also mandatory. ISBN number is optional. So, we have yes under the optional column. Same, publisher name is mandatory element, and quantity order is also a mandatory data element of the data structure book detail. Describing the data flows and data stores. The contents of the data flow may be described by the name of data structure that passes along it. In earlier example, book details express the content of the data flow that leads to process. We can specify the source and destination of the data flow. Like what we have the data flow and store, and that is the data structure in motion or rest. Like we have here an example of the same data structure book detail, having we are demonstrating here only three data elements like title of book, edition and quantity, and these are the comments related to these data structure and elements represented by data structure, like book detail from ABC bookstore, title of book, the name of the book, we are taking here the name of the subject, system analysis and design. Edition, it can be any edition, for example, we are taking here the 4th edition. Quantity of order or quantity which we have in our store, like 10 copies. A data store is described by the data structure found in it and the flows that feed it or an extracted from it. In brief, for our understanding, data flows, data structure is in motion, and data stores are the data structures at the rest. This is the all about the data dictionary overview. Now, we will move to the another tool for the structure analysis, and that is the decision tree. A decision tree is a decision support tool that uses a tree like model of decisions and their possible consequences, including chance event outcome. Once the data element are defined in the data dictionary, we begin to focus on the process. So, we have some step by step processes, like first of all we have to create the DFT. On the basis of that DFT, we create the data dictionary which have the description of the elements used in the DFT, the structure, data element, and data stores and data flows. After that, on the basis of that data dictionary, we start to create the decision tree. So, on the screen we have a sample decision tree, like first of all we have a first step, we have some starting point. There could be two conditions, condition 1 and condition 2, and on the basis we will move forward to find out some solution, to reach to any decision on the basis of this tree. It is a tree like structure. We have some parent child, you can see on the screen. So, one is the parent and it have two childs like number box 2 and 6. So, on the basis of condition 1, we move to the next step. Here we are moving from 1 to second, and we are taking some action, and on the basis of that action 1, we reach to the third point, and here we have two conditions which we have to check, and on the basis of these conditions we move to the box number 4 and 5, and on the basis of these we took some actions. Decision tree, we are going to create a decision tree. Here we have a problem or we have a statement. On the basis of that, we have to create a decision tree. The statement is related to the bookseller or publisher discount policy, like bookstore gets a trade discount of 25 for orders from libraries and individuals, 5% allowed on order to 6 to 19 copies per book title, and 10% on order of 20 to 49 copies per book title, 15 on orders of 50 copies or more per book title. So, let us discuss this statement or this problem to convert it into the decision tree. A policy statement like this can be time consuming to describe and confusing to implement, because we have some if then else statement on the basis of the policies. So, demonstrating or describing it to by words, it will be a consuming time consuming and non effective way. The analysts need to use tools to portray the logic of the policy, how that policy can be applied and how the discount will be given to the individual or librarian when they are ordering some book from the publisher. The first tool is the decision tree. When we are converting that statement to solve the logic of that type of discount, like you can see on the screen here. The first one, we start from the discount policy, and we are going to create that policy for the bookstore and the libraries or the individual. In the previous statement, I did not mention about the big bookstore, how we are going to apply the discount. So, in this I am taking two parties, they have different criteria, different on that criteria we have to take some decision and apply the discount. So, we have two parties here like bookstore or libraries or individual, and we have some conditions, and on the basis of these conditions we have to take some action. Like first of all we have the discount policy statement, and we have two type of customer here like bookstore, libraries or individual. If there are two conditions or two type of size of order for the bookstore like 6 or more or less than 6. So, discount policy decision tree can be understood for the bookstore like this. If type of customer is bookstore and they are ordering 6 or more, it means at least they are ordering 6 books and to more than 6, the discount will be 25. And the type of customer is bookstore, if any person or any bookstore is ordering less than 5, it could be 1, 2, 3, 4, less than 6, it could be 1, 2, 3 and 4 and 5. So, we have to give a discount nil, we are not going to give any discount if bookstore is ordering less than 6 book. Now, there are another condition for the discount policy, like if the customer type is libraries or individuals, we have to check further conditions on the basis of the type of customer. First of all we have to select the type of customer, and after that we will move to the size of order, and on the basis of that condition we have to take an action for the discount. Like if libraries or individual are ordering for at least 50 or more than 50, we have to give the discount, or the book publisher will give the discount of 15%. If the order size is from 20 to 49, a discount will be 10%. Same, if the order size is 6 to 19, then discount will be 5%, and same if the order size is less than 6, the discount will be nil. So, to represent graphically that discount policy, we can use the decision tree, and the decision tree for that publisher discount policy look like that. We have some conditions, we have to further sub conditions, we have to check another condition, and on the basis of the fulfillment of the criteria we will take some actions. A decision tree has as many as branches as there are logical alternatives. So, on the basis of logical alternatives, the branches of any decision tree can be extended to any number. It simply sketches the logical structure based on the stated policy. In this respect, it is an excellent tool because there are some plus point of the decision trees, which are these: it is easy to construct. On the basis of the logical alternatives, we can create that decision tree very easily, and it is easy to read or easy to understand by anyone, because it is a pictorial representation. So, it gives the information in a very concise way at a very first time. When we are seeing a decision tree, we can get the conclusion how the logically that things are going on, and it is easy to update. If there are some changes, we can easily update the decision tree on the basis of the updated statement. The decision tree shows only the skeletal aspects of the policy. It does not lend itself to calculations or so logical as a set of instructions for action. The alternative that is used for the second tool, that is called the structure analysis, and we will discuss about the structure analysis and in next lecture. Thank you. These are the references to create that PPT. Thanks again.